All right, everybody, welcome to ZeroAvia. Stand here for online audience. We are broadcasting from Paris Airshow. This is the first day, and ZeroAvia here has a nice location right in the front of the Hall 5, great by the entrance. So hopefully we're going to have quite a crowd here over the next 3 days. So today I wanted to just have a little discussion about hydrogen and aviation. Obviously, ZeroAvia is a company that produces hydrogen electric engines for commercial aircraft. So we're right there in the industry in this particular technology. But lately, I think over the last 2, 3, 4 months, there's been some movement in the discussion about hydrogen. I wanted to touch some of the bases and explain how we see hydrogen in the future of aviation, and how latest news from Airbus and some others have an impact in that. So hopefully it's going to be a great discussion and some questions from the audience online and local here at the show. My name is Val Miftakhov. I'm a founder and CEO of ZeroAvia. Started the company 7 years ago, a little over 7 years. And before that, physics background, McKinsey, consulting, Google. Built my previous company into the world's largest network of smart charging stations for electric cars. And we have nice soundtrack here of beautiful jets flying around. So really, you know that we're at the air show, yeah? It's great. And started ZeroAvia 7 years ago to really bring the future of aviation to reality. And we think that not only we need to make aviation more sustainable from the emission standpoint, but also more economical, better suited for more and more penetration into local communities, into small airports, regional air mobility. And in order to do that, we really need to move away from not just fossil fuels, but combusting fuels. So we need to move to electricity. And the only way we think to move to electricity at scale is through making storage of energy on aircraft through a chemical agent like hydrogen and convert this to electricity. So we have a couple of slides here that we're going to use as a backdrop for the discussion. And the first one is really talking about some of the recent happenings and announcements. Obviously, from ZeroAvia, we have completed our initial flight test campaign of our 20-seat aircraft or 19-seat aircraft, Dornier 228 in the UK, and that's provided a final set of data for us to submit for certification of this first engine. We made the submission 18 months ago to FAA and the Civil Aviation Authority in the UK. Things are progressing quite well on that side. Early this year, in January, we announced the certification-based approval with the FAA on the first variant of our electric propulsion system, and progress is being made on the means of compliance and also on the Civil Aviation Authority side in the UK. From Airbus, we had some interesting messaging throughout the last few months. Of course, many of you have seen the first articles that were written, I think, 3-4 months ago about Airbus potentially pulling back from hydrogen. And then they have made some clarifications and some announcements. They see some of the screenshots here for really what they said, and what they're doing is maybe pulling back a little bit on the large aircraft, the largest sort of A350 size and transcontinental across the ocean type flights, because they do depend on global infrastructure being present. Because that aircraft that I took, for example, from San Francisco to Paris just yesterday, then goes to Singapore, that goes somewhere else. And in order to operate that aircraft effectively, you do need worldwide infrastructure. But for regional aviation, you don't need worldwide infrastructure right away. You can operate regional aircraft successfully with very limited local regional infrastructure build out. And that's why we saw actually more focus on Airbus side on regional aviation. So they've announced this concept of 150, I believe, seat plane that has 4 engines, fuel cell based, So exactly the type that we are pioneering here, we're developing at ZeroAvia. And this was great to see as an expansion of the application of hydrogen electric, because the previous communications from ZeroE team at Airbus were limiting fuel cell applicability to sub 100 seat aircraft. And now we see over 100 seats being worked on by zero emission team at Airbus, which again is exactly the type of applications that we are going after. So it's really good to see there. And one of the other questions that is a frequently asked question is, okay, well, you're going to have all these engines, you're going to have this aircraft, where will green hydrogen come from? And we've seen, even over the last 12 months or so, significant progress on that. Some of the largest electrolyzer applications are being put in service. We at ZeroAvia ourselves made over 15, I think, contracts with various energy companies, energy players worldwide for provision of hydrogen, green hydrogen for our operations. We've made some launch announcements as well for some of the cargo operations, and about to make some announcement on the passenger operations as well. So green hydrogen is really available and becoming more and more available. The exciting part of that is that also the technology is already there. We know, the industry knows how to make green hydrogen. As opposed to technology for the power plants, we still don't have a certified, we are hoping to have the first certified engine on a hydrogen electric, but that's a technological barrier. And outside of that, on the infrastructure, on the airport deployments, this is all known technology and we just need to scale it. So we're really optimistic about hydrogen future in aviation. And now let's talk a little bit about why we care, yeah? So this is a reasonably depressing chart that basically shows that despite all the efforts worldwide that we're making, we're now blowing through 1.5 degrees Celsius for sure. Yeah, so this lower chart part of the chart is interesting because it forecasts the probability of exceeding 1.5 C. Yeah, and from early on when we started tracking it, it was a low probability, but then as the actions are invariably insufficient, you see the probability going up and up and up, and right now it's pretty much 100%, right? 98%, pretty much 100% that will blow through 1.5, and maybe even in maybe this year, maybe next year. So people place it probability in the 2024-29 range in that 5 years that we're living right now. So it's really important. And 1.5 we definitely will have, but what's next? And there's some studies out there that basically say if you get to 2, if you get to 3, this is really, really disruptive. So it seems like not a lot, but a lot of research agencies out there have done a lot of analysis on what does that mean actually. This 1.5 is an abstract number and doesn't seem like a huge number. But if you look at the displacement of population that it causes, the displacement of, let's say, arable lands, displacement of agriculture that it causes, and with that, the impact on the lives of people, it's huge. It's millions and tens of millions of people will need to move locations, will need to change places, and there is a very somber impact on the life of people as well. Right, the life expectancy and things like that. So there are sources out there that track excess deaths from this displacement, from the climate change, and these are quite staggering numbers. So it's not just nice to have zero emission, nice to have better economics, but it's really an existential crisis, I think, for the industry that we need to solve, and that's why it's so important. And if you look at the projection of how we're tracking on the emission side, both carbon and non-carbon are important because while aviation is just 3% of carbon budget, it's way, way higher on the overall climate impact. And because of the high altitude emissions of water vapor, high temperature water vapor, particulate emissions, NOx, aviation is anywhere between 5 and 7% today of total human climate impact. And if nothing is done, we can get to 25–50% over time, by 2050, which is just 25 years away, and a really, really problematic situation if we get there. And what's going to happen as we get closer and closer to that, we just, as an industry, we're going to get legislated out. And already people are talking about, hey, maybe we should stop flying, maybe we should fly less, maybe we should take trains everywhere. In France, I think there's already some legislating out happening of the regional aviation, which we think is actually a bad thing to do because it does not help the connectivity. Again, one other thing that's important is air quality near the airports. By now, there are a lot of studies that show very significant negative health outcomes from the emissions near the airport. These are largely particulate emissions, ultrafine particles, and the NOx emissions, nitrogen oxides, that have a very strong effect on respiratory health. So all of those, they have very significant multiples there. So you see things like, for example, diabetes and dementia, 2x impact easily, and 20% incidence rates. These are very, very high rates. And these are near major airports. And the more fuel we burn, the more of that we will see. So we really need to get away from combustion and not just from carbon. One other area of concern is, of course, noise, and especially for local aviation, for local connectivity, that's important. A lot of the communities out there are not expanding air service because of the noise constraints. Some of the largest airports have felt the pressure already as well. Like Heathrow, the third runway expansion was going on the projects for years and years, and it has, for good reasons, very strong resistance from the community, from the noise aspect, from the pollution aspect. So these are real problems, and partially problems of success for the industry. As we expanded into all these locations, as we're growing the passenger counts, as we're growing the passenger volume, cargo volume, we get more and more operations. We have more and more aircraft, and this is the consequence of success. And now we're getting to a point when the world is basically saying, well, we cannot go like this forward. We need to have the real solution. And unfortunately, just slowing down fortunately slowing down the aviation adoption is not a good answer, because aviation serves as a great connector. It serves as the industry business multiplier. So velocity of goods, velocity of business connections, all contributing to economies. And by some numbers, trillions and trillions of dollars. So the industry directly is about $1.5 trillion, but the overall economic impact is much, much higher. And we have significant opportunity to expand it further, whether through expansion of the current aviation footprint or things like VTOL operations, ground transportation replacement. This is what companies like Joby, Archer, and others are doing. All of that is significant opportunity and great improvement on the quality of life of people potentially, but we need to do it in a sustainable way. So at ZeroAvia, we of course think that hydrogen electric is a specific answer. One other vector, if you will, for sustainability that's discussed frequently is SAF, Sustainable Aviation Fuels. We think that while it is a good transition fuel for large aircraft where we don't yet have better engines available and we're forced to continue to combust fuel, SAF works. But once the electrified powertrains, power plants are available, there will be transition to those, partially because of the economics, but also because of the lack of combustion in these electrified powertrains. And once you move away from combustion, you don't have health effects, you don't have noise effects. It's a significantly better product. And we think that while SAF can work for a number of decades, especially for large aircraft, it is going to be a transition fuel. And the transition is going to happen to electrified power plants. And the best way to put electrified powertrains into aircraft is through hydrogen electric approach. So one other thing about the SAF is a relative efficiency. Here, a good mental model that you can use is that for anything scalable that can apply for a significant portion of aviation, SAF would have to be synthetically produced, which means that it's power to liquid, what's called power to liquid. And what you do is you produce green hydrogen in the beginning, and then you have carbon capture, then you have a chemical plant effectively to combine hydrogen and CO2 and carbon and produce the liquid fuel and then refine it. So all of those processes on top of green hydrogen production are extra cost. And if you do the math, that extra cost, depending on the assumptions, is anywhere between 2 and 4x of just using green hydrogen in hydrogen electric power plants. So that's one other reason, apart from all the emissions and all the noise reasons, that's maybe even the strongest reason why we will see transition away from SAF as soon as these types of engines are available for larger and larger aircraft. The economics drives this industry, and if you have something that's 4x as expensive, it's just not going to be a scalable solution going forward. Also, it's more expensive to scale, more expensive on the operating basis. So you have much higher energy inputs for SAF than inputs into green hydrogen production. Not only are you going to have the impact on the capital expense, but also on the operating expense, which is quite significant. So from every point of view, economics are not really working for SAF, again, once the engine choice is available between electric, hydrogen electric, and SAF engines. So we think that hydrogen is still the answer, and specifically it's hydrogen electric, so it gets away from combustion. And that's what we do at ZeroAvia here. Here at the show, we are presenting various components of our technology, from the fuel cell systems, high temperature fuel cells, to power electronics, to motor technology. Again, the first engine is in certification already. We're now working on a prototype for a larger engine for large propeller planes like ATR and Dash 8. We also have in prototyping and some initial concept development jet engines or jet engine replacements. We're doing work with Mitsubishi Heavy Industries regional jet for the CRJ repowering, re-engineering, and have made some significant progress there. So all these technologies we develop in-house, and of course can go into more detail here at the show on all of those. And we think this really will help us transition, have the third transition in aviation, major transition, as we've seen twice before. So first time we moved from lighter than air vehicles to heavier than air vehicles. And the driver of that was propulsion technology, internal combustion engines. And then the second transition was to commercial aviation with the advent of the turbine engines and the familiar jet engines of today. And we think that another transition of similar magnitude is coming, and it is going to be electrification transition that will make aviation truly sustainable and truly scalable, both in terms of the number of aircraft, size of aircraft, all the way up and down into local communities and the rest of the world. So really, we see this mission as a very important mission for not just aviation industry, but for human connectivity and humanity overall. So that's why we are super excited about it, and hopefully all of you are very excited about it as well. So now I think we'll take some questions if we have questions online or from the audience here. Okay, there is a question of online. What kind of thrust is obtained from the 600 kilowatt motors, and what range do you expect? Okay, so you see some of the images here of our launch vehicle for the 600 kilowatt system. It's a Cessna Caravan for online audiences. I'm pointing to our booth here. And we have a partnership with Textron, who's the world's largest manufacturer of small aircraft and small commercial aircraft, and Cessna Caravan, of course, which is the world's most popular commercial plane, small commercial plane. 3,000 of those are flying on commercial missions. And this is our launch aircraft. We're again hoping to certify the engine next year, and first full year of production in 2027. We have announced some launch operators already. This vehicle in the first configuration will have 250 nautical miles of range with IFR reserves. So 250 nautical miles plus alternate plus 45 minutes endurance after that. So fully dispatchable range. And the level of thrust is identical to the stock engine, which is the PT6, Pratt & Whitney PT6. So the way we approach our powertrain development is we are first and foremost going after the retrofit of the existing fleets or existing type of aircraft without recertification of the aircraft platform. Of course, we need to certify the engine. We need to do the supplemental type certificates on the aircraft as well, but we do not need to recertify the aircraft. And that means in most cases, we have to preserve the performance level of the power plant so that we have the climb rates and takeoff distances very similar to the stock engines. So we are looking to match that for all our initial engine introductions. Okay, great question. Anything from the floor? Yes.
What's the next major milestone for you?
Next major milestone for us. So obviously, the biggest milestone is certification. The next milestone under certification is obtaining the agreement with the FAA on the means of compliance, G2 milestone. It's underway right now. We're hoping to have it in the next couple of months here. And that's going to be the major milestone towards the certification, and really more or less last milestone before we really start producing the test results and simulation results that will then go to the FAA for substantiation. And the next big milestone is getting that certification approved and putting this into service. And this is not just a major milestone for the company, but for the whole industry, as it will be the first hydrogen electric engine of this class for commercial use. On that, thank you everybody for attending, and there will be more from the floor here. You can see it on your schedules. We have some technical presentations, we have some business development presentations, and of course, welcome to ask questions of our team members anytime. Thank you very much.